Oh, there we go. Hello, everybody, and welcome to the August Curiosity Orbit. This is, of course, my monthly live stream where we're going to be talking about everything that's happened in the world of astronomy and astrophotography. We're just going to go over the latest news just to see what all the different brands have been up to, what's been happening out there in space. But before we go into all the news segments, I actually have a few things I want to show you guys because I have quite a few things that's been added to my ever-growing fleet of telescopes. And one thing that I got this month is this little thing here. There we go. Look at that. So I found a guy who was selling a secondhand. This is an old Altair imaging scope, 8-inch Newtonian, as you can see. Very, very nice imaging scope. Comes full with. I'll show it to you guys here. You can see it comes with contrast baffles all the way in. And one thing I really like about this scope is you can see how deep down the focusing tube sits in the optical tube, meaning that it almost has a built-in dew shield. So that means if I'm lucky, I haven't actually had any chance to be out with this one yet, but I'm hoping that I don't actually have to put a dew shield on the secondary mirror on this, because hopefully it sits right deep enough in. One thing you also might notice is tube tech. I have got myself, you probably saw it when I was building it, I got a Stella Vita sitting down there, so I'm going to be playing around with the Stella Vita, see what it can do, and you're probably going to see some videos coming in the future over the winter when I begin to get some observation time with this thing. I'm going to try to put this put the Stella Vita up, see what it can do and how it stacks up against something like the SI Air. So that is something that is to come in the future. I just want to show you guys that because I think it's pretty cool, and I'm really looking forward to getting some light through this tube. Other things, you might remember, like a month ago or something, I made a video about this little thing. This is the Samyang 800mm mirror lens. So this is essentially a miniature catadioptic telescope that you put on your camera. I made a review of this, wasn't super happy with it. A lot of you guys commented that I should look into some of the older brands, some of the more vintage version of this type of lens, as they might perform better. So one thing that I'm currently working on is on this. This is the Tamron SP. This is a 500mm, and as with the other one, this is also a mirror lens. You can see it here. This is pretty cool. I think it has built-in, not the smoothest thing in the world, but it does have a built-in like dew shield that can extend out to kind of protect it. And one thing that's really nice about it is it has a super long focus travel, right? Almost 360 degrees all the way around. That means you have a lot finer focus, and overall, I think it's a much better lens. But you will see I'm working on a reviews that's going to be out sometimes next month when I get a chance to actually play around. We'll play around with this a little bit more. Yeah, thanks a lot for all the suggestions on that. The final thing that I want to show you is also just today went out and I got myself a little planetary camera. So far I've been mostly focusing on deep sky stuff, but I want to try to get into doing some planetary imaging as well. So I got a little planetary camera. This is from, the surface here is going to be really hard to focus on for the camera, but I'm going to try to see if I can get it to focus. If we do this, maybe it can. Yeah, there we go. So you can see here, it's from QHY. It is a 53290C, so it's a small color camera. Relatively small sensor, but also with a very, very tightly packed grid in terms of the pixels. Yeah, you remember the Samyang from the Star Party? Yeah, it was a struggle, to say the least. So I think the Tamron, I have actually been out testing the Tamron already. And not only, of course, it's a lighter lens, but just the increased traveling focus of focusing travel, I should say, makes it a lot easier to actually get into focus. And I've been running some rather extensive star tests on these, and the optical quality of the Tamron is also superior to what you get with the Samyang. Anyway, that was what I just wanted to show you in terms of the equipment and gear things that has been coming in the door in the last month here. So that is all stuff you're probably going to see in the channel here in the not too distant future. But let's get into the actual news, as this is why we are here, and let's see what's been going on out in the world of astronomy and astrophotography. We are going to start with this. That NASA has discovered a new interstellar comet moving through the solar system. You might already have seen this. The comet has been named 3I Atlas, so it is named after the Atlas program, or the Asteroid Terrestrial Impact Last Alert System. That's basically looking for any kind of rocks or asteroids, comets, anything out there that could be a threat to Earth. And they, of course, spotted an object moving at a hyperbolic trajectory, and therefore they know it's a interstellar. We've seen this thing is the third one they've spotted here in the last few years, so it seems like we're becoming quite good at spotting these things. I don't think it's because there's been an increased number of them. I just think we're just better at discovering them than we've been before. We can see its trajectory right here. Right now, it has passed the orbit of Jupiter and is making its way into the inner solar system. It's going to pass, as you can see, just inside the orbit of Mars, and it is scheduled to hit, our best estimate right now is scheduled to hit the closest approach to the Sun around the 30th of October. Unfortunately, at that point, Earth will have moved around, so you can see we are right here right now, and as it reaches its point here, we will be on the opposite side of the Sun, meaning we won't actually be able to observe it at that point. So if you want to actually go out and try to observe this yourself, get some pictures of it maybe, then your best bet is going to do it in September. Then it's going to move behind the Sun. You won't really be able to see it until December, when it's going to come out the other side. So you can just catch it here on the way in, and then as the Earth moves out on this side, the comet moves out here. We're once again going to begin to get some angular separation between the Earth and the comet, and we're once again going to be able to actually go and image it. So if you are interested in taking a look at it, try to image it yourself. Then September, and then you have an option again in December if the weather doesn't allow you for that. Yes, so Sky and Telescope also has a slightly newer article where they just go over some of the discoveries that have been made since then. One of the interesting things about this is that it seems to be slightly elongated. People are discussing how much of it is a cloud that's around it, how much is its shape. We don't really know for sure yet, but it seems to have a small tail. The weird thing is that that small tail seems to be pointing in the direction of the Sun, which is super weird, because we would expect, if it is a comet in the normal sense, we would expect the tail to either be pointing directly away from the Sun, which would be the most common, or like backwards in its direction of travel. But right now it seems to be slightly elongated towards the Sun, so people are still discussing exactly what that is. I also know that there's been some discussions around whether you should, or how we could be able to get observations of it as it get into its closest approach. So basically they're trying to see if they can find a way to bridge the gap where we are not going to be able to observe it from Earth because the Sun is in the way. There's been some discussions about using maybe some equipment out on Mars. Maybe we can observe it from out there, as we could see in the previous article. I think they actually also have a pretty good map here, even a better map actually. You can see Mars is here. Earth is going to move around on the back here in October. And Mars then is going to be over here. So Mars is actually going to get quite close to it, and it's going to have a pretty good chance to do some decent observation of it, and still going to have that large angular separation with the sun. So from Mars perspective, there should be a pretty good chance to observe it, even doing its closest approach. So people are discussing ways to try and get other equipment, other satellites, on other like probes that we have out there that might be in a position to see if they can get some images of it while we can't here. Ambassador Kajobi and GSC, welcome guys. Yeah, absolutely. We're live today and we're discussing the new interstellar visitor called 3I Atlas that is currently making its way through the solar system. So yeah, that's pretty cool. And I can actually, you know what? Now that we're at it, I'm just going to show you a little teaser here for something. Because there's going to be a video out, I think actually in 2 days, but I'm going to give you guys a little teaser so you can see what it is that I have discovered. Because in one of my, I was actually reprocessing some old data back from earlier this year. Actually the Star Party where Nightscape, we went to the Star Party together. I was reprocessing that data again, just to see, and I noticed this. Look at this. So I was shooting the Macarian chain. I was shooting with my mono camera, I was shooting in RGB, and as you can see here, so I saw this little like red, green, blue streaks in the image. I was very curious what that was, as it looked like something. I was starting imaging in red, then I was imaging in green, then in blue. So it looked like something was moving ever so slowly through the image while I was imaging. You can see me switching filters here. I have a video coming out in 2 days that I really hope you guys are going to enjoy, where I actually go in and observe or try to figure out what this is, and I actually do discover what it is. Yes, you're correct. It is an asteroid, but what asteroid? But yeah, that was pretty fun. So that video is going to be out in like 2 days. Anyway, that was a little sidestep away from the whole talk about the interstellar visitor. But we have next one. Yes. Let's go and talk about Betelgeuse. You guys might have seen this as well, but there's beginning to be some discussions whether Betelgeuse might actually be a binary, with the main star having a smaller. People are discussing whether it's maybe even a pre-main sequence star. Was it CK1? No, it was I3, I think they call it. Yeah, 3I Atlas. There you have it. Is the name of it. At least that's what they refer to it in all the articles I've been reading. So I assume that's the interstellar. Oh, are you asking about the not that one, the one in from Venus, from the Star Party? No. It was actually it was an asteroid that was discovered back in the 1916, I think. So it's like way old since it was first discovered. We know about this for, well, more than 100 years. Yeah, I get it. Yeah, I get it now. So yeah, the one from the Star Party. Yeah, no, it was a completely different one. But we're just going to be out on in 2 days, then you can see what it was there. Anyway, Betelgeuse. So Gemini Observatory, they have this. It's very tentative, I should say, right now. It's not 100% confirmed, but there is some indications that Betelgeuse might be in a close binary system with a small star that people are suggesting may be a pre-main sequence star. This would explain a lot of the weird behaviors we've seen from Betelgeuse, like the great dimming and stuff like that. However, as I say, this is very tentative, as their signal to noise here is extremely poor. I think they write somewhere that it is like, I have a signal to noise ratio of like 1.6 or something like that. That means there is still a very much non-zero probability that this companion they're detecting is just random noise. I think it's around 10% chance of risk, depending on how you see it, that this is just pure noise and that there's actually nothing there. But if there is a companion close to Betelgeuse, that would explain a lot of the weird behaviors, as it could be the other star disturbing the surface of Betelgeuse. There could be loads and loads of explanations why we would see this great dimming. Maybe even it could have been just moving in front of it or something like that. I don't know. But at least it is very faint. It is 6 orders of magnitude less bright than Betelgeuse, which is of course why it is so difficult to image. Their initial measurements of it says that it's around 1.5 solar masses, so it's only 50% larger than our own sun. And it sits about 4 astronomical units from Betelgeuse. That would definitely be what we consider a close binary. But yeah, as I said, it is very tentative right now. We don't really know whether it is actually there or whether this is just an anomaly, basically, just basic noise. But I think people are trying to get some more data on it and see if they can actually confirm this with a little bit more certainty. So this is definitely something I should try to keep an eye on, because it would be quite interesting if it turns out that Betelgeuse is has a binary in there. And you can then begin to wonder, like, how does Betelgeuse end up in a close binary with a pre-main sequence? It could make sense because Betelgeuse has the size that it has, Betelgeuse could actually go into its main sequence, completely burn through its main sequence before this smaller star even manages to properly form into it. It might also be that the star is just not really able to get into a stable start a stable fusion process, simply because Betelgeuse is maybe just siphoning materials off it or just disturbing it too much. There could be loads and loads of explanations why this star could exist there, but I think it's likely, most likely, that if there is a companion, those two stars would have been created at the same time. And I use stars here very, very loosely, as even if it's there, if it's pre-main sequence, I'm not really sure if I would consider it a star yet. And you're absolutely right. Still nothing from Tycho Bohr. We are still waiting. What was it? I made the guess. I can't remember what my guess was on Tycho Bohr. I tried to make like a guesstimate based on the times between the first and the second eruption on Tycho Bohr. For those of you guys who don't know, Tycho Bohr is what we call a star that's called it's a recurring nova. It's not a supernova; it's a recurring nova. They function a lot like a Type 1a supernova, where you have a larger star with a smaller one that siphons materials off it. And when the larger star then reach a certain critical mass, it's gonna go supernova. And these Type 1As is what's in astronomy is considered a standard candle, because material is slowly siphoned onto the main star. When they explode, they will often always have the exact same mass, and that means that the explosions are almost identical between all Type 1a supernovae, which is interesting because we can then, if we can detect a Type 1a supernova explosion in another galaxy, and we know how bright it should be, we can then use that to determine the distance. So these standard candles is super important for astronomers if they want to determine distance to distant galaxies, for instance. But Tycho Bohr is also a recurring nova. It doesn't go supernova because the main star is too small to actually go full-on supernova. So what happens instead is it still siphons materials off a companion star, but then it just reached a point where it just makes small surface explosions. So it's just basically shed its outer layers, but the core of the star is still intact, and the fusion process can still continue in the core of the star. And that means it can then continue to siphon materials off its companion star. And that means it can happen again and again and again. This has been observed twice, with about 80 years in between. I'm just going to see if I can find my notes on T-core bore. Let's see. I am in the completely wrong folder, so no wonder I can't find anything that looks remotely correct. Here it is. I didn't write this down, did I? I have to. Okay, then to go and find it on my online planning tool. But anyway, there's been a lot of discussions. T-core bore is due to explode, and I think if we should just have the exact same time between the first and the second explosion as we have between the second and the third one we're about to see now, I think it was November something where it is scheduled to explode, but there's been a lot of discussion around it. Then it suddenly began to dim and it began to brighten up, and like all kinds of like weird fluctuations with it. So people were discussing whether that explosion was actually close. But we need to remember that we really only have 2 observations of it. So we only have 1 time period that we are measuring here. So there is a lot of uncertainty here. We don't know how much that varies between explosions and how regular these explosions are going to be. But at least nothing from T-core bore yet. We are still waiting for that thing to explode, which hopefully should happen this year. If not, I think it's pretty certain it's going to happen next year. I hope. I'm still betting on November, but we'll see if we actually get there or when it will actually happen. But I know that I'm keeping an eye on it. And I know there are other people that regularly point the telescope in that direction just to see if anything has happened. And I'm pretty sure most of also the larger professional telescopes, they swing by from time to time just to see if anything is up with T-core bore. Yeah. So both Betelgeuse, interesting to keep an eye on. T-core bore, also interesting to keep an eye on here in the near future. Let's move on to some gear and software updates. What's been happening in the software side of it. ZWO has released version 2.4.1 for the ASI Air. You might remember last month we talked about the 2.4 update that was released that's caused a number of issues. And back then I talked about how they were currently working on an update for it to try and fix a lot of the issues that was in that update, especially around abnormal meridian flips. And also when you use the auto exposure when taking flat field, then it had the tendency to overexpose your flats, which of course is no good. That has now been fixed. It actually came out quite shortly after last month, so this is why this is a little late on this. But at least those things should have been fixed together with a number of other things. So if you haven't updated, I think 2.4.1 is the latest version. I'm not sure if they have done another one, but at least that should be fixed now. There's also been some new hardware releases from ZWO. More specifically, they now have the ASI 662 MM. The MC has been out for quite a while, but the new thing is that we now have a MM, so a mono version of the 662. And this, as we can see on this spec sheet here, it has relatively small pixels with a 1/2.8 inch, so small sensor as well. It's actually not like stat-wise, it's pretty much identical, not quite, but very, very closely resembles that little camera I showed you here at the beginning of the live stream in terms of sensor size, in terms of pixel density. Those like 2.9 micron pixels works really well on stuff like a 2000 millimeter focal length telescope, stuff like that. You don't want to go much lower on, I think, on a 2000 millimeter, like an 8-inch. I've been trying to find, because the reason why I've been looking for cameras for my Schmidt Cassegrain. This is an 8-inch 2000 millimeter. And I have been ideally looking for something around a 2.9 micron pixel size, even though you can get smaller. But if I go smaller, I'm probably gonna oversample quite badly. I'm gonna go beyond the ray length limit of my telescope. So that's why I've been looking for telescopes in this kind of spec range, and I thought this one was interesting. So yeah, that is out now. We can see this is the color here. We have the light response. This curve is a bit misleading, I think, because as you can see here with the new version, it has a maximum quantum efficiency of 91%, which is pretty good. But they show it as so when it raises 1 here, that's the 91%. So this is the max output it can. This is the max sensitivity it can get. So it means you really only get that 91% quantum efficiency around 650 nanometers of wavelength. Interesting though is it actually performs quite well. Usually, if you put an UV IR cut filter on this, you would usually cut it around 400. And you would cut it on the upper end around 700 here. So there will usually only be this range here where you would be imaging if you were using an IR cut filter. I mean, but this actually performs quite well all the way out to like 800 millimeters. So this can actually go quite deep, quite deep into the infrared and still perform quite well. What that means in terms of like how stars can feel bloated and stuff like that, I don't know, but at least it seems to have some decent performance, even beyond what the usual UV IR cut filters would allow it to. But anyway, that is out. New camera from ZWO. Skywatcher, on the other hand, has also been busy, not with cameras, but with telescopes. I'm not sure if it's something that came out this month, but I just noticed that they came out with this. This is the Skywatcher HAC 125DX minigraph, and this is a an f2 catadioptric design. So this has a 250 millimeters, so it's very, very wide. So it's a very wide field of view, but it's an f2, meaning it is extremely fast. Small 5-inch, so it's not super big, it's not super heavy. I think the total tube weight, don't they list the tube weight somewhere? It was quite light, like 3 kilograms. Optical tube weight is 8.4 pounds. Now, that is 3.8 kilograms. So rather light. Interesting though is a 16 millimeter image circle means that you are not gonna be putting like any larger sensors on this. You're gonna put very, very small camera sensors on this. Probably something not like too far off from what we were seeing with these small lipstick cameras, because even a crop sensor is gonna be way too big for the image circle here. Let me just see if I can find one of those camera sensor size images thingy-mabobs. Yeah, this one is, I think I found one here that's pretty good. No, hold on. Oh, I found it. Here we go. Let me just get that up there. Okay, good. This one. Okay. So, camera size-wise, you can see here, if you put a full-frame camera, if it has an image circle of 16 millimeters, I mean, it's not even going to be able to be half the length of a full-frame camera. So, full-frame, forget about it. It can just barely cover the height of a crop sensor, but that still means you're going to get massive vignetting in the corner. We can see here micro four thirds, still too big. We have 17.3 on the long edge. You could probably put a 1-inch sensor, but I think that is really pushing it, because now we are at 12.8 on the long side here, and you have to remember that this is the radius, so actually the diagonal here that we are interested in. So I think a 1-inch is probably as much as you can push it before you begin to see some serious vignetting on something like this. But ideally, you want to probably go down to something like 1/1.2 or smaller than that. But this is, you need to get small sensors on this if you want to get any kind of serious imaging out of this. So that's one of the drawbacks of using a sensor or a telescope like this. But I think it's interesting. I don't know what it is about these smaller telescopes I just find so fascinating, that you have these tiny telescopes. And I know that, yeah, you should, like, aperture is definitely has something, but it's still a small 5-inch, 3 kilograms, something you could just, easily pack up and take with you and go out and have some fun with. Do they show the back? So that's the front. No, hold on. Where's the front here? So there we have the... I just wanted to see if there were actually collimation. Oh, that's the focus knob here. Okay. But it doesn't look like... Oh, maybe there is. There's a screw there, then there. Maybe there are collimation. Yeah, there is. Look at this. Okay, I was just wondering if you could actually collimate this thing, but you can. So you can see here, you probably have set screws. I'm going to guess you have set screws in those 3 there. Must be expensive. Oh, yeah. You probably have set screws in those holes there. You can loosen those, and then maybe these are the locking screws, but I would guess the bigger ones here would be the actual adjustment screws for the secondary, or that would actually be the only mirror that is in this, because you can see here, the whole design is built around that you put the camera here on the front of the telescope, so it really only goes through the corrector plate, down hitting the mirror at the back, and then out the front. There's no secondary mirror on this. Price-wise, now this is in Danish kroner, which of course is not very useful for a lot of people. So let's just make that into US dollars. So it's around $1,000 for this. It's pricey for the size of telescope, for sure. But I mean, we've seen worse. Looks like it comes with a built-in, or not built-in, but it has a dew shield that can be screwed on here on the front. Anyway, I thought these are fun. I really like these small, tiny telescopes. I actually saw one when I was at the expo in London, not from Skywatcher, but this one, the Carbon Star here. Again, same price. This is again Danish kroner, so they're about the same price-wise. They're about the same. I saw this one in person, and I don't know what it is about these tiny, small telescopes. I just love them. Yeah. Let's see if they have... Where's the spec sheet for this? Here, specs. So you can see it is quite a bit fainter. Now we're down to an f4. Slightly bigger aperture. The other was a 5-inch. This is a 5.9, so pretty much a 6-inch telescope with a 600 millimeter focal length. And if you remember the other one we were looking at from Skywatcher was a 250 millimeters. But that's of course what you get when you get up to that f4. That then of course you could get a little bit more focal length out of it. Secondary mirror central obstruction. That's not the image circle, is it? Surely they don't have a secondary mirror central obstruction. That would be an extremely large image circle if they can actually fit. Do they say anything about how big of a sensor they can fit on this? I'm not sure if they do. Yeah, okay, so this one, it's actually say here. Yeah, okay, so they say that it will take crop sensor and full frame. So remember our picture from before, where here with this with the skywatcher you have to use these smaller sensors. This will actually go all the way up to a full frame if you want to. But they also say that it actually shines a lot better, it works a lot better with smaller sensors. So what they're saying is probably don't use crop and full frames on it. You're probably gonna get a bit of a Yeti. You're gonna have some very, really good flats if you want to do that, but use smaller sensors and you're gonna get a great time with it. Anyway, that one that was out from Skywatch is relatively new. I just thought it was pretty cool. I love these small telescopes. Okay, let's move over and let's talk about the night sky here in the months to come. So let me just quickly get Stellarium open so we can look at what's going to happen in the next month. But what do you guys think? Are you guys interested in these like smaller scopes? Because I live in the city, and that means I travel with all my telescopes. And I need to pack all my telescopes and like transport them. And I can understand if you have a more static setup, then having a larger telescope is not a big deal if you just have to move it out of a shed. But for me, this, as you saw in the beginning, is pretty much the limit of how much I want to travel with if I want to go anywhere. 8-inch optical tubes is pretty much my limit for how big of a telescope I think it's fun to put in the back of my car and drive around with. Bigger than that, it begins to get quite cumbersome and also very heavy. So these smaller setups, I think is pretty fun. Anyway, let's go and have a look at what's going to happen in the month of August in the night sky. Now, the main, where is it? There. We have the Perseids, which is a meteor shower that's going to be active here during the month of August. Depending on where you are in the world, it can be a little bit difficult, I think, for some people to observe. Up here north, it's actually quite easy. We have very good separation to the moon, which is over here. And it sits quite high in the sky. This one will actually never set here when I'm this far north as I am right now. If we just quickly remove the atmosphere here and we fast forward, you can see, we can actually also just turn on that grid there. You can see that that circle here is actually never going to set. So we're always going to have this available up here. But if you are further south, then maybe you're not going to have an as easy time with that. It is going to be, it's going to be peaking at around the 12th. So we'll just quickly move forward to the 12th. Here we go. To the night of the 12th. Oh, that's midday. No, damn it. Now I managed to go to the day. Okay, hold on. We're going to do it the old-fashioned way then. Go. Well, there we go. So it's going to be available towards the northeast up here, where it is going to be peaking, and it peaks with a, there we go. It peaks with a zenith hourly rate, as you can see right here, at around 100 meteorites or meteors per hour. And we can see here I set it to the 12 here, where it has 99. It is one of the, I think it's the third most active meteor shower that we have. So it is going to be quite active, and it's the only one we have at this time of the year. I actually think the two others, let me just check. I have here, if you don't know, in my book, The Cosmic Field Guide, if we just quickly, I always have this at hand. And if we look at there, page 14, there is a very nice little table here with all the meteor showers throughout the year. And we have the one we're looking at right here. And as you can see here, it is listed right there, 13th of August being the day it's most active with a zenith hourly rate of around 100. We have two others, one in January, one in December, that is more active at around 120 meteorites per hour. So, but this is going to be one of the more active ones. By the way, if you're interested, my book, you can get that on deepspacebooks.com. There should be a link in the description. But anyway, that is one of the main things. But actually, around the 12th, there is a lot of stuff happening around this day. First of all, if we just remove the ground here, the Moon and Saturn is moving quite close to each other. Let me just go ahead and remove that grid. So you can see here, if we fast forward here, if we can just center on the Moon. Can't remember when the closest approach is. It's a little earlier, I can see. Let's go back here. And we're also at the 13th now. We need to go back to the 12th. Around there. So around the 12th, the evening on the 12th of August, we have a relatively close approach between Saturn and the Moon. So the separation is a little bit too big to be able to properly resolve Saturn, so you can see that it's actually the planet. You need to get a little closer, I think, for that. But there is a relatively close approach, so if you are doing maybe visual astronomy, then there is a chance there. But on the same night, we're still here on the 12th, where we also have the meteor shower. We also have, if we can just find Jupiter. Whoop. There we go. Jupiter and Venus also having a relatively close approach. Let's see if this is the closest, or if they get closer than this. I think that is about as close as they're going to get. It looks like it's moving away. See if it moves close in the other direction. There. That's about as close as they get. And this is actually close enough that you might actually be able to see Jupiter and Venus in frame at the same time, and actually be able to see that it's Jupiter and not just two dots of light. So another close approach just around the 12th of August. So that's really going to be an active night. If you are interested, and you can see here, you have, of course, Orion, we have the Belt, we have Betelgeuse that we just talked about here, and then Jupiter sitting right up here. It is relatively close to the Sun, as you can see here, so it might be difficult to actually get some observations in. As you can see, this one is actually during the day where that happens for me here. So depending on where you are, it can be difficult, and you might have to be lucky and just get it. Looks like this is going to be a morning thing. It's going to be the best option you're going to get, at least from where I'm at. Might be able to get some early morning shots here. So I have to go like 4:30 in the morning would probably be the best time for me if I wanted to try and get a shot of this here. Oh, fuck, can't see it. Damn it. Okay, sorry. Let me try that again. So what I was saying was, God, that we have the Perseus. Oh, we talked about that. Yeah, it was when I was showing the book. Okay, now we have on the 12th, we have that close approach between Jupiter and Venus, as you can see here. There you go. And as I said, it was relatively close to the Sun. Sun's coming, we have Mercury coming up here, and then we have the Sun here. So the angular separation to the Sun is not that big. And that means that you're probably going to have to get out pretty early in the morning if you want to have a chance of catching the Jupiter-Venus approach. But as you can see here, there is actually separation here is relatively low. So there's a good chance that you're going to be able to maybe get Jupiter and the Galilean moons together with Venus in frame. And also on the 12th, of course, we had the close approach between the Moon, Moon and Saturn. So you can see that here. Just fast forward, and let's just move the ground. Whoa, Moon. What's happening here? There we go. Let's go backwards. there. So this is on the 12th in the afternoon. This is probably not, at least here in Denmark, the sun's probably still going to be up when we have the closest approach, and it's actually below the ground as well. But there is a chance there at least, whoa, this is weird. There's a chance there at least that you can see, where's the sun now? Sun is there, so this would probably also have to be a early morning thing just before sunrise, I would guess, if we take it back there. Yeah. That means the variation is going to be a little bigger, but at least there is a chance with a wide angle that you're going to get Moon and Saturn in the same field of view, if you're interested in that. Okay, so a lot of things happening here towards the middle of the month with both the meteor shower happening and of course also a few close approaches if you're interested in those kind of things. Good. I think I reached the end of my list. That is what I had for you this time. I really hope you enjoyed it. As always, I would love to invite you guys to join us over on the channel's Discord server. Growing community of our astronomy and astrophotography interested people. As you can see here, people can register themselves as either mentors in different categories. So if you want to help people out, you can go and do that, or you can just ask questions as people have been doing in the various channels. If you want to share your photos, you can do that. You can see I've also shared the picture here of the asteroid that I found. People sharing their images, people are sharing their equipment. When people find cool stuff, they show it over here, and if they need help with their equipment, then people also go and share. And I sometimes also post pictures over here when I'm building up my telescopes. You can see a little bit behind the scenes kind of stuff. There's a lot of stuff going on over here. If you're interested, do join it. There should be a link in the description below this video. Okay, that's gonna be it for today. Thanks a lot, guys. I hope you enjoyed it. And as always, if you find anything interesting that you think I should cover in next month's iteration of Curiosity Orbit, then on the Discord server, there's also a dedicated channel for that, where you can go and you can post your news. And a lot of the news that I've been covering today is from stuff that I came across and I've been posting in the Curiosity Orbit channel, and then we can talk about them. So, thanks for watching, and clear skies.